Okay, Abdullah.
আমার অ্যাকচুয়ালি আচ্ছা আমি আসলে জেনারেটরস তারপর হচ্ছে ওই অংশগুলোর পর একটু জিনিসপত্র একটু মানে খুব একটা পরিষ্কার না।
General, okay. In the Lie group part?
হ্যাঁ মানে লি অ্যালজেব্রা
Okay.
হচ্ছে কিভাবে মানে লি গ্রুপের সাথে কানেক্টেড।
Okay, yeah, that's a very good question.
I have issues too there.
Yeah, I can, I think I've done that twice already, but I'm happy to do it the third time. So let me give you a qualitative picture first, okay? So what is the connection between, say, a Lie group and Lie algebra, right? So a Lie group is a manifold, right? So a manifold is just a space, some sort of space which locally looks like an Rn. Okay, so this is some sort of Lie group. Okay, so if I take a random point in this group, it has some coordinates, right? Theta A. Suppose it's an n-dimensional manifold. Then how many coordinates will it have? It will have n coordinates, right? Right? You understand that?
Yes, sir.
Yeah. So, what does this? So, for example, if you had a sphere, those coordinates could be some angles, right? There could be some angles like theta, and it could be phi, right? If it was a two-dimensional sphere, except a two-dimensional sphere is never a group. So a three-dimensional sphere is group. Okay, so now, so this is, you can think of this as the coordinates. And the way that we generate these coordinates is we do some projection. We basically have some Rn and we do some projection. Okay. We saw the stereographic projection, right? So far, I have not told you anything about group. All I've told you is that how from a manifold we can generate some coordinates, okay? Now, what makes this manifold a group is that associated with these coordinates, there is a group element. Okay. Okay. But how is that group element related to these coordinates? So there's a group element G. So there's a group element G, and here are the coordinates. So the coordinates are theta A, and the group element must be a function of this theta A, right? So far, so good?
Yeah, makes sense.
স্যার এটা কেন থিটা এর ফাংশন হতে হবে?
Well, the Lie group is a manifold, right? Every point on this manifold is a group element, right? That's how it's defined. A Lie group is defined to be a group which has continuous parameters, and therefore they have to be part of some manifold. Okay, so on this side, you have coordinates, and A goes from 1 to, say, n. And here you have the group element. So There must be some, so if I give you this, you should be able to tell me what this is, right? Okay?
Yes, sir.
So the bridge between these things, so these are some matrices, right? Okay, we don't care about the dimension of the matrix now. They are just some matrices because they're group elements. They are Lie group, they're matrix groups. We don't care what the dimension is right now. So there is a bridge between them. The bridges are the generators, which are also matrices. Okay? And the formula that allows you to go from this guy to this guy across the bridge is this. EI sum over A, theta A, TA. Okay? So if TA is a matrix, do you agree that this is also a matrix?
Yes.
Yes, sir.
Okay. So in general, this matrix does not explicitly depend on these parameters, right? Okay. So this we identified to be the group element, which is a function of the, I'm using theta A, but what I mean is the whole set of thetas. Maybe if I were to be a mathematician and be I should use the set notation. Okay. So this is a group element. And these are the coordinates on the manifold / the parameters. And these are the generators. Okay, now let's do an example, shall we?